So in the last lecture, we did the graph also. So did we do any numerical for Henry's law? Yeah, we did some numerical, right? Okay, fine. So today, write the topic limitations of Henry's law, and then we will move on to the next topic, that is vapor pressure. Limitations of Henry's law. Okay. All of you can see the screen, yes or no? Please tell me.
Yes.
Yes. The limitations of Henry's law. Please write here. The first thing is that the pressure should be low. Okay. The pressure should be low. Now, when there is high pressure, what happens? When there is high pressure mein, if you have high pressure, please listen, don't write. In high pressure, what will happen? Gas can turn into liquid. Yes or no? Because you are compressing it and gas is compressible. And if gas is compressible, then it will become liquid. And as we increase the pressure, the gas, it loses its ideal nature. Hai? If you compress the gas, then what will happen? It will lose its ideal nature. And that is why it will be more and more becoming like liquid. And that is why Henry's law will not be applicable, because Henry's law is applicable only if you have gas in liquids, right? If you have gas in liquid. Is that clear? The first point, yes or no? Please tell me.
Yes.
Okay. Write the next point. Now, similarly, if the temperature is too low, the temperature should not be too low. The temperature should not be too low. Okay. Why? Again, because if we decrease the temperature, then also what will happen? Gas can turn into liquid. Hai na? Gas can change its phase and turn into liquid, and then Henry's law will not be applicable. Is that clear? Yes or no? Please tell me.
Yes.
Yes.
Okay. The next point is the gas should not be highly soluble. Now, if the gas is highly soluble, then what is going to happen? There will be no vapors here, right? There will be no vapors from the gas. If the gas is very much highly soluble, there will be no vapors from the gas. Okay. The next point is the gas should not be very highly soluble. Right. The third point and the last point. Sorry, fourth point. Now it goes without saying you should have a solution. And in order to have a solution, the components A and B, the solute and solvent, they should not react with each other. Now, if they're reacting with each other, they will be forming new molecules and new compounds, right? So the last point will be the gas should neither react with solvent, nor dissociate or associate, in solution. Okay, so please write these 4 points. These are the limitations. Waiting for Dania and Hanifa. Please write this down. Let me know when you're done. And after that, you all will write the topic, that is vapor pressure. Write the topic vapor pressure. Okay, all of you are done. चलिए बहुत बढ़िया. Vapor pressure. Okay, so before starting, you just write the topic and listen. Write the topic and listen. If I have a container like this, in this container I have some water. Okay, I have some water, and then I close the container, and I have just closed the container, and I have put a lid over it, and after that I leave it overnight. I leave the container overnight. Don't write anything. Just listen. Now, in the morning, again, what did I do? I saw that when I saw the lid, there were some water droplets. Okay. Now, what does this mean? It means that as the time passes, slowly, what is happening? Some of the water molecules from the from the liquid, it is getting into the gas phase, and in air also you will have water in the form of humidity, right? H2 as a form of humidity, and H2 molecules, since they are gaseous molecules, they will be moving in a random motion. And what can happen? They can also strike the water surface, and since the water surface is going to be cool, what it can happen? It can turn into water that is liquid. So all of these things, two things, evaporation and condensation, right? So gas is getting evaporated, and there is also condensation that is happening. Both of these things are happening in this container, and that is why all of the gaseous molecules which evaporate, and so when they are evaporating, what will happen? They will move here and there, and slowly they will come to the lid, and the steel that is lead here, steel will be having some lower temperature than air. Steel will be having lower temperature than air, and that is why they will again condense here, and they will form water droplets on the lid. Okay, now what does it mean? It means that if you see this whole picture here, you will come to know that there are two things which are happening. There is evaporation happening. If I talk about the liquid, we are just talking about a liquid, evaporation happening, and there is condensation happening. Okay, so when evaporation happens, then liquid, it transforms to gas, right? Vapor, or I can say liquid, or liquid to gas बोल सकते हैं. Condensation में you will have gas to liquid, right? Gas to liquid. Okay. Now, one question is that after the overnight, if you keep the container overnight, like this only, will there be any considerable change in the amount of water? क्या पानी बहुत कम हो जाएगा क्या? It will be same. You will not see any difference. Yes or no? If you leave it overnight also, will you see any difference in the amount of water in the container? Tell me, Dania, Alina.
No.
No, na? So basically nothing is happening to the water. Yes or no? Tell me. Nothing is
Yes.
happening, na?
Yes.
No, nothing is happening. And please remember, now since all of you are new, that means you are not with me in 11th standard. So when nothing happens, we say that it is equilibrium. Okay, what is equilibrium? When you can't see any significant change in the macroscopic property. Okay, if I look in the microscopic way, or if I look in the molecular way में देखेंगे तो आपको पता चलेगा कि yeah, there is liquid which is converting into gas. Something is happening. Gas is also converting to liquid. But what is the consequence of liquid converting to gas and gas converting to liquid? Nothing, right? So nothing is happening macroscopically. If you want to see the naked eyes, you will not see any change. Will you remember this point? Yes or no?
Yes.
Nothing is happening macroscopically. Okay. Equilibrium में क्या होता है? It is a state where nothing happens. It is a state nothing happens. Process होता है and then equilibrium. So there is some process. Some process can happen. After that, there will be equilibrium. Okay. Now, from here we can write many things. And if I want to define the vapor pressure, what will be the vapor pressure? So evaporation and condensation both are happening, right? That is why both of these will be in equilibrium, right? Evaporation and condensation, both of these things will be in equilibrium. Rate of evaporation will be equal to also rate of condensation, and whatever gas molecules you are forming due to the evaporation of water, that is the vapor pressure. That is the vapor pressure, whatever pressure is there. Achha. First of all, let us write about the vapor pressure definition. So the partial pressure, please write with me. The partial pressure the partial pressure of vapors in equilibrium with pure liquid at a given temperature is called vapor pressure. Is called vapor pressure. The partial pressure of vapors in equilibrium with the pure liquid. है ना? In equilibrium with the pure liquid, those are known as, I mean, whatever the pressure that will be applying on the container's wall, that pressure is the vapor pressure. That pressure is vapor pressure. Okay. Now at equilibrium, what happens? At equilibrium, the rate of evaporation should be equal to rate of condensation. Rate of evaporation will be equal to rate of condensation. Now, what does that mean? It means that there will be H2O liquid. It will get converted into H2O gas. And this H2O gas will also get converted into H2O liquid. This is the equilibrium here. Now, whenever there is equilibrium, we can also write the equilibrium constant, that is K. Equilibrium constant K is the amount of product. Now, here we have gas. So gas, we can write in terms of pressure of H2O gas. Now, divided by, here we have liquid. Now, this H2O is a pure liquid. And all of you know that if we have pure liquid or pure solid, its concentration or pressure is given as 1. So we are writing Kp here. So we can say that Kp is equal to the partial pressure of H2O in vapor phase or gaseous phase. And also remember, see, this is the vapor pressure. And this pressure is also what? This pressure is same. This pressure is the vapor pressure here. This pressure is the vapor pressure. Okay. Now, as you can see, vapor pressure is what? It is an equilibrium constant. So this is vapor pressure. This is vapor pressure. Okay. Please write this down. Let me know when you are done. Alina is done. Waiting for Dania, Hamza, Hanifa, and Zaid. Hamza, you are late. What happened? Time से आने की कोशिश कीजिए, है ना?
Yes, sir.
Okay, Zaid is done. Waiting for Hamza and Dania. Dania is also done. The topic is vapor pressure, Hamza. Is everyone done? Yes or no? Please tell me. Hamza, लिख लिया आपने?
Yes, sir.
Okay. Now to raise your hand. Okay, fine. Now, next point will be factors affecting. Please write with me the topic. Factors affecting the vapor pressure of liquid. Okay. Now I have a question for you guys. Please don't write anything after this. Okay. When I will tell you, then only you will write. Write the topic. Factors affecting vapor pressure of liquids. Okay. If I compare sanitizer and water, what do you think? Which will have more vapor pressure? Sanitizer or vapor? Sorry, sanitizer or water?
So water.
Water. What about others? Yes, Alina, tell me. किसका ज्यादा होगा vapor pressure?
वाटर का होगा.
वाटर का होगा. Okay, Hanifa, what do you think? Water. Okay. How many of you think water? Please raise your hand. Okay, Hamza, you think sanitizer will have more vapor pressure? Yes, Hamza.
Sir, I don't know, sir.
So you don't know. Okay, fine. So vapor pressure तो उसी का होगा जिसका ज्यादा vapor बनेगा. Yes or no? Please tell me. है ना? If you will
Yes.
have more vapors, then the vapor pressure will also be more. All of you agree? Zaid, Dania, Hanifa, Alina.
Okay, sir.
Yes, sir.
Okay नहीं. Okay,
Yes, sir,
okay
yes.
कौन बोल रहा है? Okay नहीं. हाँ. If you are not convinced, let me know. ठीक है? Okay, fine. If you have more vapors, there will be more vapor pressure. Okay, fine. That means if something is easily getting converted to vapor, जिसका evaporation बहुत आसानी से हो रहा है, that will be giving me more vapors and that substance will have higher vapor pressure. Is that clear? Yes or no?
Yes, sir.
Ease of evaporation देख के चलेंगे ना, which is getting evaporated more easily. If it is getting evaporated more easily, that means more vapor pressure also. Okay, now you tell me, you take water and rub it on your hands. Your hand will be wet or dry. If you take water and rub it on your hands, your hand will be wet or dry.
So wait.
All of you agree, right? Yes,
Yes.
or no?
Yes, sir.
But
Yes,
what if you take same amount of sanitizer and you rub it over your hand? Your hand will be wet or dry?
So dry.
Dry. So tell me, where is the evaporation faster for sanitizer or water?
So sanitize.
Sanitizer. If the evaporation is the rate of evaporation is higher in sanitizer ही बोलते हैं ना, sanitizer ही बोलते हैं ना. So vapor pressure will also be higher, है ना? So now the first thing that you can see here is it depends on the nature of liquid. If you take two different type of liquids, its vapor pressure is also going to be different, है ना? Now what are the factors that affect, like what we have to see inside the liquid, that I will explain you. But the first factor that you will write is the nature of liquid. Please write with me. Hamza, आपको समझ में आया? Yes or no? Please tell me, Hamza.
Yes, sir.
Okay, nature of liquid. Nature of liquid. Now, if something is evaporating very easily, that means its molecules are not sticking together. Yes or no? If something is evaporating easily, right?
Yes.
Its molecules are not sticking together. That means the intermolecular forces of attraction is not strong, right? So you will write liquids with strong IMF. What is IMF? Intermolecular forces of attraction. Liquids with strong intermolecular force of attraction have low vapor pressure. Have low vapor pressure. Now the next will be very easy for you guys. Tell me, what will be the effect of temperature? Temperature को बढ़ाने से vapor pressure बढ़ेगा या घटेगा?
Sir, increase.
Increase.
It will increase, right? More and more vapors will be formed, and that is why the vapor pressure will also increase. So you'll write here vapor pressure of volatile substance. Volatile substance, that means anything that can evaporate, and a volatile substance increases with increase in temperature. With increase in temperature. Done, guys? Yes or no? Please tell me.
Yes.
Yes, sir.
Now, next topic is boiling point. Who will tell me what is boiling point?
So the temperature at which the liquid evaporates at constant temperature and pressure.
Sure. So what is the boiling point of water? 100 degrees Celsius. Okay. And what is the general normal room temperature? Yes, Zad, tell me. What is the room temperature? General room temperature?
Temperature 25, I think.
Correct. 25 degree. ठीक है? It is 25 degree. Okay. It is 25 degree, right? So 25 degree में evaporation नहीं होता है क्या? Tell me, guys. Does evaporation happens in 25 degree? Yes or no?
It's not complete.
Huh? नहीं.
Maybe.
You're saying no. If you spill some
Sir,
water
no.
on the floor, if you spill some water on the floor, then
Yeah.
it will evaporate, right?
Yes, yes.
So why you're saying no? Tell me boiling point then. Yes, guys, tell me. Think. What should be the definition for boiling point? For this, we can do is a small thought experiment. In thought experiments, you don't know anything. You don't know anything. You just need your thoughts. You need just your brain. Okay. So this is a container. There is water. Don't write anything, huh? Just listen. And then you are heating it. Okay, and you are heating it. Now this lid is not, this is not airtight. ठीक है, आपको बस उसके ऊपर lid रख दिया है ना. You have just placed the lid on top of the container. Okay, so you are heating it. Now while you are heating it, what did you go? You went a bit far away and you are must aram se sitting here. Okay, and you are sitting here. Okay, you are must aram se sitting here. Fine. You can just see what is happening in this place. Okay. Now tell me, will you be able to tell when the boiling is starting? आपको पता लगेगा?
No,
If you're sitting.
Yes, sir.
Yes, Alina, tell me, how will you know that the boiling started?
When it starts to vaporize in like.
नहीं, vapor कैसे दिखेगा आपको यार? You can't see vapor. हमेशा vapor नहीं दिखता ना?
जी.
Boil होता है ना? हमेशा तो नहीं दिखता है ना? Lighting का. तो boil होगा नहीं, तो आप तो दूर बैठे हैं ना, कहाँ से दिखेगा आपको? ढक्कन भी बंद है.
जी.
You're sitting there. Okay, think.
There will be pressure exerted on the wall of the container.
उसके दिखेगा क्या आपको, वो बताइए, जिससे पता लगेगा कि boiling start हो गई. What will you see that will confirm that boiling has started?
सर लिड के ऊपर हल्का सा प्रेशर वो पता चलेगा, which is getting exerted by the vapor.
ये बोलने का मतलब आपका लिड हिलने लगेगा, राइट?
यस सर।
है ना, तो यही दिखेगा, ये जो दिखेगा वो दिखेगा ना। प्रेशर वगैरह तो आपको साइंस का टर्म्स है ना, विच वी हैव polished it and we have framed it and we have defined it, but what you will be seeing is that lid will be moving. Now let us see what is happening. So we can say that whenever lid moves, if the lid starts to move in normal conditions, earthquake नहीं आया तो it is boiling. Yes or no? All of you agree? The lid will start to move a bit.
Yes.
All of you agree, right? तो हम लोग ये बोल सकते हैं कि हमारे हिसाब से बॉइलिंग, तो बॉइलिंग पॉइंट वो है जिस टेम्परेचर में लिड क्या होने लगे, हिलने लगे, राइट? बिकॉज वी आर जस्ट सीइंग इट. नाउ लेट अस ब्रिंग साइंस इनटू इट. नाउ फर्स्ट ऑफ ऑल, व्हाई इज लिड स्टेबल इनिशियली? पहले क्यों नहीं हिल रहा है? बिकॉज देयर इज अ प्रेशर ऑफ 1 atm हियर. यस और नो? देयर इज एन एटमॉस्फेरिक
Yes.
प्रेशर ऑफ 1 atm. नाउ बाद में क्यों हिलने लगा? बाद में इसलिए हिलने लगा बिकॉज इफ वी इंक्रीज द टेम्परेचर then more vapors will be formed, and if more vapor is formed then what will increase? The vapor pressure will increase. Vapor pressure will increase. Pressure will increase. Pressure will increase. Pressure will increase. And if the pressure is equal to 1 atm, the vapor pressure of liquid is also equal to 1 atm, then now the lid will start to get disbalanced a bit, right? It is getting force from above also and from below also, right? That is why it will get a bit disbalanced, and then you will see that it is moving. All of you understood this? Yes or no? Please tell me.
Yes.
यस सर।
So boiling point is the point at which vapor pressure, it is equal to the atmospheric pressure. Got this? Yes or no? Please tell me.
Okay.
यस सर।
Yes ना? किसी को कोई डाउट नहीं है? No doubt, right?
नो सर।
Okay, fine. So please write for boiling point the temperature at which now just imagine if we did not have these kind of vocabulary like vapor pressure, है ना, and atmospheric pressure. If these terms were not there, इसका ये मतलब नहीं कि हम लोग boiling point को identify नहीं कर पाते. We would still have identified boiling point, लेकिन उस टाइम हम लोग का जो vocabulary रहता, जो definition रहता, that would be, I would say that they will be having some loopholes there, है ना. Now this definition that science has given, it does not have many loopholes. The temperature at which vapor pressure of a liquid is equal to the atmospheric pressure or you can write external pressure. Or external pressure. Also, one more point we can write: liquids having high vapor pressure have low boiling point. So boiling point is inversely proportional to vapor pressure. Also, you can also write boiling point is directly proportional to intermolecular forces of attraction. अगर intermolecular force of attraction ज्यादा होगा तो boiling point भी ज्यादा होगा. Please write this down. I'm waiting for Dania, Hamza, and Zaid. Please raise your hand when you're done. Okay. Now, this is very important. See, when you have pressure, for example, this concept of boiling point now, uh, it can be applied. It can be applied, and for example, in pressure cooker, what happens? We apply external pressure. There is some external pressure. As soon as you airtight the pressure cooker, there will be external pressure, right? And due to this external pressure, the boiling point, the external pressure increases. That is why you will be requiring more. The vapor pressure should also increase, right? And the boiling point increases. So rather than at 100 degrees Celsius, the water boils, right? But what happens if I apply external pressure? Then the boiling point increases to 120 degrees Celsius. If you're cooking at 120 degrees Celsius and if you're cooking at 100 degrees Celsius, then which will require less time? This 120 degrees Celsius will require less time. Okay. So that is why what happens if we cook food in pressure cooker, food is prepared more fastly. Food is prepared more fastly. It doesn't take much time because we are applying external pressure. If external pressure increases, then what should happen? The boiling point will also increase. That means more and more temperature will be required in order to the vapor pressure to reach the external pressure. है ना? अगर ये 1 atm से ज़्यादा होगा, so it will be more than 1 atm. Whatever the pressure cooker is applying. Okay, so that is why what happens? Food gets prepared more easily in pressure cooker. Okay, next is a law, Raoult's law, which combines what is the vapor pressure when we have two different types of solutions. Okay, when we have two different types of solutions. So we'll understand what is Raoult's law, and after that, we will write the statement of Raoult's law. We'll write the statement of Raoult's law. Okay. So write the heading, then I will explain. Okay, write the heading Raoult's law. Raoult's law. Okay. So in Raoult's law, we should have two liquids. Say liquid A and liquid B. Okay, liquid A and liquid B. Let us make liquid B red color. Okay. And there will be vapors just above A. And there will be vapors just above B. Okay. Now, if I mix these two things, then I will have, let us see, the solvent is A. So majority is blue. And then you have red, that is solute here. Similarly, you will have vapors of red and vapors of blue will also be there. Okay. So it is a Raoult's law. It explains what is the relationship between the amount of solute or solvent that you are using, the amount of component, and the vapor pressure, whatever vapor pressure it is applying. So here, if I talk about the P total, in this case, P total, it will be the partial pressure of A plus the partial pressure of B. Okay. Now, when it is pure A, then I will say that the vapor pressure of pure A is P naught A, and the vapor pressure of B is P naught B. Okay, vapor pressure of pure A is P naught A, vapor pressure of pure B is P naught B. But when we mix them, then obviously the P total will not be equal to P naught A plus P naught B, because these are for pure solutions only. These are for pure solvents, pure components only. When we are mixing some things, then what is going to be happening? Then there will be some There will be some pressure due to A, there will be some pressure due to B. Raoult's law explain what will be this pressure. Okay. Now this statement is not very significant. या फिर उसको समझना बहुत ही मुश्किल नहीं है. If I say the partial pressure due to A is directly proportional to the amount of A present in the solution. That means the mole fraction of A that is present in the solution. So all of you understood this point, right? Yes or no? It is completely logical that if I
Yes.
have more A, then the partial pressure of A will also be higher. Yes or no? Alina, Hanifa, Zaid, Hamza,
Yes.
right? Okay. Now, in order to remove this proportionality sign, I will write partial pressure of A is equal to some constant K and the mole fraction of A. ठीक है यहाँ तक? No problem?
No problem.
No problem. Now, in order to get what is this K, what I will do, let mole fraction of A is equal to 1. Now, when mole fraction of A is equal to 1, what does that mean? It means in pure A, we have the pure A, there is no B present. Now, what will happen? PA, it will be equal to K, yes or no? Because mole fraction is 1. Correct? Hai?
Yes.
Now, we also know that the pressure of pure A is equal to how much P naught A. That means we can say that it implies that K is equal to P naught A. Yes or no? Please tell me. All of you
Yeah.
understood this, right? Dania, Hanifa, Alina, tell me. All of you understood this, now? K is equal to P naught. That is why PA will be equal to P naught A chi A. Similarly, what I can write, PB, partial pressure of B will be equal to P naught B chi B. Okay. And that is why the P total will be equal to P naught A chi A plus P naught B chi B. Okay. Now this statement here, now this first statement, this is the Raoult's law. Okay, the simplest, very simple and very easy to understand. Very easy to understand. So all of you will write the Raoult's law. Please write with me. For a solution of volatile liquids, for a solution of volatile liquids, for a solution of volatile liquid, the partial vapor pressure of each component, the partial vapor pressure of each component is directly proportional to its vapor pressure. Its vapor, sorry, I'm really sorry. What did I write? Directly proportional to its mole fraction. Okay, so it is saying PA is directly proportional to chi A, है? Similarly, PA will be equal to K into chi A. And if I write at chi A is equal to 1, PA is equal to P naught A, है? And that is why K will be also equal to P naught A. K will be equal to P naught A. And hence we can write, substitute the value of K in the previous equation. So we'll get the partial pressure of A is equal to the pure vapor pressure of A into the mole fraction of A. Okay. Into the mole fraction of A that is present in the solution. So please write this down. So the statement of Raoult's law, it is this statement. Okay. The statement is this, and whatever we have done after that, it is application. So we are applying Raoult's law in a solution. So please write this down. Let me know when you're done. Waiting for Dania and Hamza. All right. For a solution containing liquid A and B, for a solution containing liquid A and B, the total pressure is equal to partial pressure of A, the sum of partial pressure of both the gases, na? Whatever the contribution of A is there and whatever the contribution of B is there. If I apply the Raoult, then I can write P total will be equal to P naught A chi A plus P naught B chi B. We also know that as chi A plus chi B is equal to 1, then what we can write? We can write P naught A into chi A will be equal to what? Chi A will be equal to 1 minus chi B. You can write 1 minus chi B plus P naught B into chi B. Now, if I will expand this, so this will be equal to P naught A 1 minus chi B. P naught A हो जाएगा minus, it will be P naught A chi B plus P naught B chi B. Now, what I can do here, I can take this chi B common. This will be P naught A plus में क्या है P naught B है पहले, so P naught B आ जाएगा minus P naught A into chi B. यहाँ पे आपका क्या आ गया है P total. Now see, this is very important. This is a very important formula. Then all of you, yes or no, please tell me.
Yes.
Okay, now listen here. See, why is this very important? Why is this very important? If you look into this equation, and if I have you have been given a container, in that we have two different type of liquids. We have liquid A and we have liquid B. Okay, we have liquid A and we have liquid B. If I want to calculate the mole fraction of this particular solution, if I want to calculate the mole fraction for this particular solution, and we know that A and B are gases. Okay, A and B are gases. We know what is A and what is B. What is A and what is B? Both of these are sorry, A and B are not gases. My bad. A and B are liquids. Okay, both of them are liquids, not gases. Both of them are liquids. So we have a solution of two different liquids, and we want to calculate the mole fraction for it. अगर आपको ऐसी कोई कंटेनर लाके दे देगा और बता देगा कि इसमें क्या है, let us say A is H2O and let us say B is ethanol, है ना, ETOH. Now what is the mole fraction of ETOH here? What is the mole fraction of ETOH? Then how will we calculate? How will we calculate? This formula will now come. This formula will come. How? What we will do? We have this whole container. Please listen very carefully. We can find the P total. How we can find the P total? We can just put up a manometer or a barometer and measure the, and we will measure the P total. Yes or no? Please tell me. ये कर सकते हैं हम लोग?
Yes.
Right? We can measure it. Okay. That means this is done. Now, can I get the P naught A? अभी अगर आपसे कहा जाए कि please find the P naught A. That means the pure vapor pressure of A, the vapor pressure of pure water. Then you can find that. You can easily Google it and you will get the P naught A. Similarly, you will get the P naught B, and you will also get the P naught A. Right? Now, what is the only thing that you don't have in this equation is chi B. Now it is a simple linear equation in one variable. Now, if you see what is the power of theory, you can see from here. You can see the power of theory that we have two different liquids and there is no other way to calculate the mole fraction. There is no device that you can have to calculate the mole fraction, right? So what we are doing here, we are measuring a simple thing, that is the total pressure, and from this we are getting the information about very molecular and very atomistic information, that is the mole fraction. That is the mole fraction of ethanol here. Okay, so P total is always going to be measured. Okay, so if you have any question in which they are asking you to calculate the P total, so that question may be important, जो एग्जाम में बहुत बार पूछा गया हो, but please remember that is a bad question. Why it is a bad question? Because if we want the value of anything, as I must have stated earlier, there are two ways. We can either calculate it or we can or measure it. If there is a simple tool for measuring, then we should always measure the value, right? We should always measure the value. For example, आपसे अगर कोई वॉल्यूम देके क्यूब का वॉल्यूम दे दिया किसी ने, आप पूछ लिया लेंथ बताओ, है ना, लेंथ बताओ, तो ये सवाल देने के लिए तो अच्छा है आपके मैथ्स के एक्सरसाइज के लिए, बट इफ यू सी रियलिस्टिकली स्पीकिंग, आपको किसी ने क्यूब रखा, ऐसे क्यूब रखा हुआ है ना, उसका आपको वॉल्यूम देके लेंथ पूछ रहा है, देन यू विल गो pick up your scale and then just measure the length, right? So if there is tools that is easy and cheap tools present to measure something, we will never calculate. नहीं लिखेंगे हम लोग कि वॉल्यूम का क्यूब रूट करेंगे तब जाके हमको लेंथ मिलेगा, नहीं भाई, स्केल लेंगे सीधा से जाके मेजर कर लेंगे हम लोग. ओके, and we use calculations only when you have something complex and which cannot be measured. For here, the mole fraction cannot be measured, that is why we are calculating it. So P total should always be measured, and if there is any question in which you are asked to calculate the P total, that question may be important, but that is a bad question. Is that clear? Yes or no? Please tell me. You understand all in all for this equation P of Raoult's law?
Yes, sir.
Everyone tell me. Dania, Alina, Hanifa.
Yes, sir.
Yes, sir.
Yes. Okay, fine. Now we will study the graph for Raoult's law. Okay, this graph is very important. Please write the topic. Graph for Raoult's law. ठीक है, डोंट राइट एनीथिंग, है ना, प्लीज डोंट राइट एनीथिंग. अगर लिखेगा कुछ समझ ही नहीं आएगा. ठीक है, ग्राफ इज अ बिट कॉम्प्लिकेटेड, लेकिन कुछ स्लोली हम स्टार्ट कर रहे हैं, प्लीज ध्यान दीजिए आप लोग. Here we have pressure, and in this direction I am marking the mole fraction of P. ठीक है, no doubt till here, yes or no? Please tell me. कोई दिक्कत यहाँ तक?
No,
No, sir.
No. Now tell me, at this point chi b will be equal to how much? Mole fraction of B
So
will be
zero.
equal to 0. यानी कि एक सोल्यूशन है जहां पे आपके पास क्या है, सॉल्यूट नहीं है, सॉल्वेंट नहीं है. व्हाट इज बी? सोल्यूट और सॉल्वेंट? बी इज
solute.
solute, है ना. So you have a kind of, you have a solution in which there is no solute, that means only solvent is present. Correct है? Yes or no? Please tell me. Alina,
Yes.
Hanifa, Dania.
Yes, sir.
Right, now we can also write if chi b is equal to 0, then chi a will be equal to how much?
1.
1. All of you agree? Yes or no? Please tell me.
Yes, sir.
Okay, now if we are having pure solvent, then the pressure will be the vapor pressure of pure A. Yes or no? It will be the vapor pressure of pure A, na?
Yes.
Right, so this will be P naught A. Correct hai? All of you agree with this? Yes or no? Please tell me. This will be
Yes,
P
sir.
naught A. Dania, Alina, Hanifa, I need a yes sir from everyone.
sir.
ठीक है ना? ठीक है, अगर नहीं समझ
Yes,
में आया तो
sir.
no sir, समझ में आया तो yes sir, because each and every point is very important. Okay, similarly chi b कहाँ तक चल जाएगा? 100 तक, 1000 तक तो नहीं जाएगा, है ना. It will be 0.1, 0.2, 0.3, 0.4, 0.5, and it will end 0.8, 0.9, 1, है ना. chi b mole fraction cannot be more than 1, so this will be a point where chi b will be equal to 1 and chi a will be equal to 0. Is that right? Yes or no? Please tell me.
Yes, sir.
Now let us suppose that now in this point we have chi b that is equal to 1. That means here we are having pure B. We are having pure B. We are having pure B. Then the vapor pressure will also be equal to P naught of B. Is that right? Yes or no? Please tell me.
Yes, sir.
Okay. Now let us again see, starting from here. At this point, when chi b was equal to 0, I can say that the pressure due to B, if B is not present, the pressure due to B will also be equal to 0. Yes or no?
Yes, sir.
है ना? And slowly what is going to happen? And slowly what is going to happen, as we increase the amount of B, the pressure due to B will also start to increase. And as chi B reaches to 1, the pressure will be equal to P naught B, which is the partial pressure or vapor pressure due to pure B. When you have pure B, that is the partial pressure. P naught B is the partial pressure of pure B. है ना? So this will be the line. So this line will be telling me about PB. This line will be telling me about the partial pressure due to B. Okay. Now, all of you understood this red line? Yes or no? Please tell me. बताइए.
Yes, sir.
Okay. Now, when I look at A, so initially, when there is only A, at this point we have only A because chi B is equal to 0, chi A is equal to 1, and slowly what is happening? Chi A is 1, and then it is decreasing, and coming to B, coming to 0. Now, when chi A is equal to 0, when chi A it is equal to 0, the pressure due to A will also be equal to 0. The pressure due to A will also be equal to 0, right? Because we don't have any A. So this line here, that is the blue line. This blue line is giving me the information about how the partial pressure of A is changing. है ना? The partial pressure due to A is changing. How is PA changing? Okay. Now, when I join from the point which is PA to P naught A to P naught B, this point, this line here, it is showing me the P total. It is showing me the P total. This black line is showing me the P total. That means it is giving me the sum of PA and PB. Partial pressure due to A and partial pressure due to B. So please write this down. Let me know if you have any doubts.
Sir, is it necessary like P naught B will be above like P naught A?
नहीं, यहाँ पे बस एक assumption है. The assumption is P naught B, the partial pressure क्या? It is more. That means that means B is more volatile than A. ठीक है? B is more volatile than A.
Okay.
This is the assumption here, है ना? That means the rate of evaporation or the ease of evaporation is higher in B. B gets easily evaporated, and that is why its pure vapor pressure is also high. Done all of you, yes or no? Please tell me. Alina is done, Zad is done, waiting for Dania and Hamza. Hanifa got disconnected. Okay. And waiting for Dania and Hamza. Hamza, please raise your hand if you're done. Hamza, please raise
Yes,
your
sir.
hand
I'm
if you're
done.
done. Okay. Now write a question. So this question is very important. Okay. This has been asked multiple times. This is very, very important. Write the question: vapor pressure of chloroform and dichloromethane at 298 Kelvin are 200 mm of Hg and 415 mm of Hg respectively. First, अच्छा, there is one correction in the question. ये solution नहीं है, in vapor phase यहाँ पे लिखिएगा. Okay, all of you have written the question, yes or no? Please tell me.
Yes.
Now, in this question, we have one information. What is the information that is given to us in this question? Tell me. See, the information that is given to us, first of all, is the pure vapor pressure of chloroform is 200 mm of Hg, and for CH2Cl2, it is how much? 450, 200 and 450. That means they have given me P naught of CHCl3. This is equal to 200 mmHg and P naught of CH2Cl2. This they have given us 415 mm of Hg. Next, the question is calculate the vapor pressure of the solution. That means they're asking this vapor pressure of solution. That means they're asking what? P total. Solution का मतलब क्या हुआ? P total only. So they're asking P total. Okay. Prepared by mixing. Now they are giving me amounts: 25.5 gram of CHCl3 and 40 gram of CH2Cl2. Fine. So this is the most important information, that 25.5 grams of CHCl3 and 40 grams of CH2Cl2 of CH2Cl2. These are being mixed. Now, from this information, we have been given the mass of a substance in both the cases, right? So for both of them, we can calculate the number of moles. Yes or no? Please tell me.
Yes.
Is equal to how much? The given mass divided by the molar mass. Similarly, for number of moles of CH2Cl2, this will be also equal to the given mass divided by the molar mass. Okay. Chaliye. So what is the given mass here? Tell me. What is the given mass for CHCl3?
So 25.5 grams.
अच्छा, दानिया, अलीना और हमजा आप लोग को नहीं दिख रहा है क्या? और आप लोग को ये नहीं समझ में आ रहा है हम क्या पूछ रहे हैं? यस, दानिया, अलीना एंड हमजा, टेल मी।
So I don't understand this one.
क्या नहीं समझ में आया आपको? बताइए।
यहाँ पर वो हमें ये कैसे पता चल रहा है कि यहाँ पर ये टू क्या बोलते हैं NCHCl3 जो है उसमें से लाइक W क्या है और फिर MM क्या है, मतलब।
W इज द गिवन मास। नंबर ऑफ मोल्स आपने निकाला होगा ना क्लास 11th में।
जी जी,
नंबर ऑफ मोल्स कैसे निकालते हैं? गिवन मास बाई,
मोलर मास।
वही लिखा है हमने, ठीक है।
ओके।
ठीक है, सो व्हाट इज गिवन मास? टेल मी। बोल भी तो रहे हैं, हम तो बोल भी रहे हैं, आप सुनिए भी तो। आप
जी
लिख रही हैं क्या? आर यू
जी, मैं
राइटिंग नाउ?
लिख रही थी। जी।
नहीं नहीं, लिखनी लिखेंगे बात, ठीक है। आई विल टेल यू व्हेन यू
ओके।
हैव, ठीक है। So given mass by molar mass. What is the given mass for CaCl3? Tell me. What is the given mass?
25.5।
है ना? Very good. 25.5 grams. What will be the molar mass? Molar mass कितना हो जाएगा?
क्लोरीन इज 35.5, राइट? सो 35.5 यानी कि 5 5 5 15 15 और उधर 5 5 5 1.5 and 15, then it will be 16.5, then 90, and then you have carbon and hydrogen. Carbon and hydrogen will make up 13. So वहां से हो गया आपका 6 और इधर 9, 6 3 9 ना, हाँ 119 हो जाएगा। 119.5, 119.5 grams per mole. Okay, so we will calculate this value. Next is the number of moles of CH2Cl2. The given mass here is 40 grams divided by molar mass for CH2Cl2. तो 71 71 71 71 71 और 14 85, 85 grams per mole. Okay, 85 grams per mole. So calculate both of these values. I think I remember this must be like 0.47 या 0.48 के करीब कुछ होगा for NCH2Cl2. NCH3Cl3 please calculate कीजिए और send me in the chat, ठीक है? When you are done calculating, send me in the chat. Okay, Alina and Zad has given me some answers. I think Zad, it will be not. Yeah, correct, Alina. ठीक है, waiting for few more. आप okay. दानिया, हमजा, आप लोग भी आंसर भेजिए।
What happened, Dania and Hamza? Dania, are you calculating?
Yes, sir.
जल्दी कीजिए, फिर इतना टाइम नहीं लेना चाहिए, है ना? बताइए इतना टाइम लगे कैसे होगा? Hamza, what about you? ठीक है, सेकंड का ठीक है, फर्स्ट का बताइए हमजा। दिस वन इज फाइन। हाँ, this will be 0.21 moles. ठीक है, we have got the number of moles for both the things. We can also calculate the mole fraction for both of them, right? So the mole fraction, that is chi of CHCl3 will be equal to the number of moles of CHCl3 divided by number of moles of CHCl3 plus the number of moles of CH2Cl2. So this will be equal to number of moles of CH3 is 0.21 upon 0.21 plus 0.47. This will be equal to 0.21 divided by 0.21 upon 0.47. आ जाएगा 7 1 8 4 2 6 0.21 upon 0.68. Write this as 21 upon 68. ठीक है, इसको कैलकुलेट कीजिए कितना आएगा। Yeah, yes, correct, Alina. This is 0. This will be 0.308. Okay, calculate it. Now CH2Cl2 will be equal to 1 minus CHCl3, mole fraction of CHCl3. This will be equal to 1 minus 0.308, which will be equal to how much? 296. 296692. 0.692, है ना? And after that, you can calculate the P total. So although it is a very important question, this is a bad question because they're asking you to calculate the P total, which can be easily measured. P total is equal to the PA, partial pressure of A plus partial pressure due to B, and PA plus PB. इसको हम क्या लिख सकते हैं? P naught A chi A plus P naught B chi B. What is P naught A? P naught A के बारे में हम क्या लिख सकते हैं? CHCl3 कितना है? 200 mm ना? So right, P naught A is 200 mm of Hg multiplied by mole fraction, that is 0.308 plus P naught B is 450 into P naught B is 0.692. Okay, so if you calculate these two values, कितना आ जाएगा? 308 का डबल, 308 का डबल कितना हो गया? 100 से मल्टीप्लाई करेंगे तो 30 30 60 और 16 61.6 प्लस 415 इंटू 692, तो लगभग 7 है। चलिए कैलकुलेट द अदर वन, उसमें यू हैव टू मल्टीप्लाई 415 इंटू 0.692,
So 287.21,
कितना आ रहा है?
287.1.
287.1. ठीक है. Okay. Now if you add both of these things, then what will be the answer?
सर वो 18 है या फिर सिर्फ 1 है? 287.1 या
नहीं, आगे 18 हो सकता है 18, नो प्रॉब्लम. ठीक
ओके.
है. हाँ. So this will be equal to how much? 348.78 mm of Hg. ठीक है. Done guys, yes or no, please tell me.
Yes.
Now next question. Next question क्या था इसमें? इसी में next question था mole fraction of each component in vapor phase. है ना? यहाँ पे हम लोगों ने जो मोल फ्रैक्शन निकाला ना, प्लीज रिमेंबर ये मोल फ्रैक्शन नहीं है, ये क्या है? ये मोल फ्रैक्शन तो है, बट दिस इज फॉर द सॉल्यूशन फेज, राइट? सो दिस आर द मोल फ्रैक्शन फॉर सॉल्यूशन फेज. What we have calculated? We have calculated that there is a thing like this, and we have some other element also. So calculate the chi A and chi B of the solution phase. Now, if I cover this, there will be some vapors here. There will be some vapors due to red also. You have to calculate the mole fraction of the vapor phase. That means this phase here. We're just talking about this phase. Okay. So while we have chi A and chi B here, we can say that we are going to calculate the YA and YB. ठीक है. So mole fraction of vapor phase को हमने कैसे define कर दिया, कैसे denote कर दिया? YA और YB से. Is that clear? Yes or no? Please tell me.
Yes.
Okay. So we are just denoting the mole fraction only, but in we have written mole fraction is what? YA and YB. Now, according to Dalton's law, you know, what we will use? Dalton's law of partial pressure. According to Dalton's law of partial pressure, it says that the partial pressure of any component A, and if you have a mixture of gases in that, if there is any component A, the partial pressure of A, it is equal to the mole fraction of A into the total pressure. Okay, so this is what? This is Dalton's law. So we will use Dalton's law and we will calculate the pressure of, you can say that pressure of CHCl3 is equal to the mole fraction क्या लेना है यहाँ पे? YA. Okay, YA means Y of CHCl3. Y of CHCl3 into the P total. यहाँ पे जो P total आया वो कितना आया? P total आया हमारा 348.78. From here we can calculate Y of CHCl3 is equal to what? It is equal to the pressure of CHCl3 divided by the pressure total. Pressure of CHCl3 सिर्फ कितना था? देखिए ये वाला है ना CHCl3 का. This thing is for CHCl3. This thing is for, this is the partial pressure of CHCl3. This is the partial pressure of CH2Cl2. So partial pressure of CHCl3 was 61.6 divided by 348.78. दोनों mm of Hg में, that is why there will be no units. You have to calculate this, है ना? Now बहुत सारे ऐसे लोग होंगे जिनको ये चीज याद नहीं होगा, Dalton's law of partial pressure. ठीक है. So right now what I will suggest is that do this. अब बस अभी आप लोग कीजिए इसको, कैलकुलेट कीजिए, फिर हम बताते हैं ये क्या है ना. We will derive this also. Write this down. This question is important, and why they have asked this question many times is because the initial part is very easy. In initial part, you don't have to do anything, but as soon as you come to the second part, it is completely confusing. Even though the solution is very small for that, even the calculations is not very much there. But the second question just deals with which chapter, not solution. It deals with the states of matter chapter, that is an 11th standard. है ना? So यहीं पे ये चीज difficult हो जाती है because we are not using anything. We are just using the values that has been given as that we have calculated from the previous section. That is the first question. That is the first part of the question. जहाँ पे हम लोग क्या use करें 61.6 and 3048.78. But conceptually speaking, this complete question is from states of matter. ठीक है? That is why it has been asked and it is a favorite question of CBSE. चलिए please write this down. Let me know when you are done. Calculate करके chat में भेजिए answer. I've got one answer. Let us see. Okay, Zed. Okay, Dania has also given me answer. Waiting for Alina and Hamza. So you all are getting this as 0.18, hai na? Approximately speaking, 0.18. So similarly, the mole fraction of CH2Cl2 will be equal to 1 minus 0.18. So this will be equal to how much? Actually, अरीना का भी वैसे ही आंसर आ रहा, तो ये हो जाएगा आपका 0.82. ठीक है? So these are the mole fraction of vapor phase. These are the mole fraction of vapor phase. चलिए. Now please raise your hand if you want me to explain this highlighted part. Raise your hand if you want me to explain this part here. अच्छा नहीं, सबको आता है, याद है सबको डाल्टन स्टॉक पार्शियल प्रेशर? ठीक है तब. Okay, fine. Now there's one announcement for you, all of you guys. Tomorrow, there will be a test. Okay, there will be a test on app. Okay, on the portal. App या फिर वेब पोर्टल जो भी आप यूज करते हैं उसमें होगा. ऐप में देख लीजिएगा या फिर पोर्टल में. The web portal, whatever you are using, you will use that. There will be a test that will be MCQ. Okay, this test will be MCQ. Okay, and what else? Yeah, topics. Topic will be solubility of solids and gas in liquid. एक तो solubility होगा अपने आप में टॉपिक, ठीक है, of solids and liquid in gas. Gas and liquid में एक टॉपिक आता है जो आपका important, that is Henry's law. ठीक है, so Henry's law will be there. Okay, then आज की क्लास में हम लोगों ने जहां तक Raoult's law से पहले that means vapor pressure. ठीक है, vapor pressure, factors affecting vapor pressure. Okay, then boiling point, all of these things will be there. So we have three topics: solubility of solids and gas and liquid, Henry's law, which comes under the previous topic only, and vapor pressure. So these will be the topics. Tomorrow you will have test. You can give the test at any time. अच्छा, last Sunday का test किसी ने दिया था? दानिया, अलीना, हमजा, जैद.
Sir, that happened online?
हाँ, ऑनलाइन ही था.
Yes, yes.
दिया था आपने जो MCQ था?
No, sir, that happened online. We gave. About
नहीं.
MCQ, I don't know.
नहीं, ऐप में आपने नहीं दिया ना?
No, sir.
नहीं. What about you guys? दानिया, अलीना, हमजा?
No, sir.
नहीं. Okay, have you guys registered on the app या फिर पोर्टल वेबसाइट में कहीं पे भी आपने रजिस्ट्रेशन भी नहीं किया आप लोगों ने? तो रजिस्ट्रेशन कर लीजिए, है ना, उसमें भी 24 घंटे लगभग लग जाता है. So you have the contact number of Learnivio, है ना? If you have any problems while you are registering, please message them. Okay, please message them. Get yourself registered in the web portal or the ऐप, ठीक है, मोबाइल ऐप जिसमें भी, आई थिंक वेब पोर्टल वर्क्स बेटर इन सऊदी. सो गो टू Learnivio